All right. So for something a little bit different now, let's talk about how we at our company are now deploying Kubernetes on vessels that are floating in the middle of the ocean. So we are PGS, so we are a marine geophysical company. We acquire data for oil and gas exploration and renewable for wind and carbon capture. But the main thing is that what we acquire is a huge amount of data, petabyte size kind of thing, and we use a lot of compute power in order to process it. Which means that when we do acquire data, we actually have an entire data center on the vessels. Those can be pretty big and look like normal data centers with racks and cooling, with like 50 to 100 servers, like a few thousand cores, and 500 terabyte to 1 petabyte of storage on site. That's needed because the boats are actually like acquiring up to 2 terabyte of data per 24 hours, so pretty big volumes. And they need to do the quality checking, conditioning, a lot of like processing before the data can be actually sent off. But we also have people living on the vessels for like 6 to 8 weeks. So as they're working and living there, they need access to like corporate systems, all the different business resources that they will need in order to do things, and also have a little bit of access to the internet. But there is no broadband, there is no like DSL or anything like that when you are back in the ocean. So for a long time we rely on geostationary satellite, which have been great, but are very far away. So latency is very high and bandwidth is very low. Fortunately, over the last few years, low orbit satellite and mostly Starlink have been really great for us, making sure that we now have access to high bandwidth and, most critically, low latency. So what does that mean for PGS in general? Is that for the last few years, we've been on a journey to actually get rid of our data center and move into the cloud. And that has been a great transformation for our IT development environment and platform in general. We had some great achievement, and we decommissioned most of our compute capacity on-prem in the last few years. But that also meant that for the vessel, as we will be decommissioning all our compute resources, we will also start moving all the data into the cloud and having a common ecosystem basically that process things directly in the cloud. So what we realized when we were doing this is that we had a great opportunity for modernization, but that was going to require something a little bit more than just a few new tech. We needed to actually build an actual platform. We had a lot of growing pains when we started to migrate to cloud native. We've seen a lot of teams having issues with embracing technology, doing a lot of greenfield projects that ended up being very disparate or have one of a kind thing everywhere. And it was very hard for the teams to basically reproduce what they were doing from one project to another. So we also had a lot of people that were developing new applications that were just saying, I don't care about how the cloud works, I just want to build and ship something. So it was quite difficult. And we were going to Kubernetes, but we didn't just need Kubernetes, we needed a full-on platform. And this is also the idea of a golden path, making sure that, there is a preferred way to do things. And we consolidated that idea for us into a few things that, as much as possible, need to be self-service. People need to be able to come in, pick whatever they need, and then, don't have to ask IT, get a ticket system, and wait for weeks to get something done. We wanted to use industry standard. For a long time, we had a lot of build your own things your own way at the company, which is great, but it also means that when you onboard somebody, it takes them 2 years to actually get any efficiency. So not great. So we wanted to be a little bit more using what exists out there that we can leverage. We had a bit of a traceability problem and a bit of how we deploy things problematic. So we early on said that we wanted to be GitOps. And rollout and application health visibility was a big problem. There was that silo thingy where you ship your thing and somebody else deploy it and everything. Nobody understands is the application actually correctly rolled out? Is it in a good shape? This kind of thing didn't really feed back to the developer properly. Our policy is a bit of the same vein, is making sure that we can have a consistent environment, especially when you consider like vessels, like they are a fleet, and they definitely need to be managed as a fleet. Back to the idea that the developers needed to care less about the platform or like infrastructure IT stuff. We needed the battery included environment where just you come in, it works, you got everything. And we couldn't really like hire a bunch of people and like add them to every developer teams. We needed a core team that was like being able to do platform engineering for the entire company. But yeah, the vessels got a little bit more tricky. We don't have actual like technical people on the vessel. We have operation people that run like the acquisition, but we don't have an IT service or department on the vessel. It's a critical operation, so like if the vessel is down because IT has an issue, this is very problematic. This is a lot of money for us to lose by when we're done. And it needs to be really consistent. Like the users, the developers, and even the operators of the vessels, they are on shift on different vessels at any point in time. So you can't have things that are done one way in one place and differently anywhere. So fortunately for us is that we've been working with Google for quite a bit of time, and we were quite happy with GKE, like a managed Kubernetes platform. And Google started to like roll out what they call distributed cloud virtual for bare metal, which is very mathful, but it basically just means like deploy GKE, the managed service, on your own hardware. So this is what we started to do. But first, we needed to say, okay, how are we going to do that? And because we are like platform engineering and we wanted to codify things, we actually started to roll Terraform modules that actually allow us to deploy clusters. And those basically make sure that we can standardize, which is one of the goals we had, make sure that we have consistency over, and also like manage cluster lifecycle remotely without having to have people doing the upgrades or anything. And we ended up with a pretty nice but pretty long pipeline, at least in like how far things have to travel. Effectively, what we use is our GitOps repository, so GitLab, to make sure that things are codified and then checked in. That kick off a pipeline that talk to the Google APIs that themselves use Starlink to connect back to the vessel to provision our cluster or Kubernetes clusters. And then there is a connect gateway which allows us to actually have access to the cluster and do whatever we want with it. The problem is that now you just have a Kubernetes cluster there. Your developers, they don't want just that, they want a lot more. So this is where we started to use ArgoCD for like our actual GitOps deployment. And what we realized that we could do something really funny, which is that use clusters that are dedicated to manage other clusters. So we have a bunch of ArgoCD clusters that manage workload cluster, what do we call, that are like the admin cluster are hosted in Google, and they actually like drive the other cluster to configure them and to deploy the other add-ons, so all the batteries basically that we need for developer to work on. So things like being able to like have access to HashiCorp Vault, so they can have their secret and outside the cluster, and don't have to check that in Git. Do certificate and DNS management, all this kind of thing that are automated in Kubernetes, but don't come natively. And what it provided us is a very great experience for the developer, and especially a very consistent experience for the developer. Because if they deploy something in the cloud or on-premise, onshore, or on a vessel, it's exactly the same logic and exactly the same process. So they use ArgoCD, they have a nice UI that allows them to follow their deployment, to understand like, okay, what's happening. Everything is checking in Git, all their manifest for whatever, and then it just like push it to the cluster they selected to deploy to. And that happens even on a vessel that is like sailing in the middle of the ocean. We still have a few remaining challenges. Starlink is great, but has some caveat. The fact that it doesn't have stable AP means that exposing things out of the vessel is a little bit more tricky. Some of the features that we use in the cloud are not available. So like identity web proxy isn't one of the big things, but it's okay. Or integrating with things that are on the vessel is a problem. Like high performance systems that don't have a CSI driver or things like that. Or integrating with traditional network segmentation. But the thing is that this is exactly the same problem you will have in any other environment, not just a vessel. So we're back to actually having problematics that are like like any other data center, which is great for us. And this is my talk.